Okay, good morning. What I will do, I will go through this home assignment today. Of course, they are a little bit above the level of the book, but the knowledge that you need to solve this problem is not outside what we learned. Okay, we went through some of them. I mean, the ideas should be familiar to you. But as I told you before, factory polynomials is not a simple task. It needs experience. And even if you bring a subtle one to me, even though I have worked a lot about this, might be I cannot solve it myself. Okay? So this shouldn't demotivate you. But hopefully, if you follow what I told you, you can solve the majority of them. Some of them are a little bit harder, needs a little bit creativity, and some trial and error, by the way, when it comes to factoring. Okay, so the first one, okay, do you remember I told you that the priority is always given with the method that you learned from Ma3c, and that is if there is a common factor to all the terms that you can pull out, the first thing you have to do is that one, and then it might not be complete yet, then you have to ask another question. Can I continue forward or not? Okay, some of you, when I was checking the solutions, I saw that you didn't bother to factor a 2 out. You immediately factored this combination out. This is not wrong, but that is not complete because you see 4, 6, and 10 are also all divisible by 2. So the first thing that you do is to pull out 2 from the numbers. Can I pull also an A? A is also a common one, so I have to pull that one also out. What more? You see 3x minus 4 squared means this one multiplied by itself, so I have 2 of these factors in the first term. I have one of those factors here and one of those. Oops, I think that is wrong. Yes, let me see.
That's a Y.
Yeah, let me show you. See, that was my mistake. This is the correct question. Yes, so that should be 3x minus y. So let me fix it and then continue. Okay, so I pull this one out as well. Pulling out means you need to write 3 questions, you need to fill up 3 question marks so that when you multiply this back in, you will get all these things back. Okay? So what should I write here? 4, 2 is pulled out, 2 is left, because 2 multiplied by 2 is 4. I had 1a, I pulled it out. Technically speaking, 1 is left instead of a, but we don't bother to write because 2 times 1 is just 2. And here I had 2 factors of 3x minus y. I have pulled one of the factors. What is left? Another factor of that. You can always double check by multiplying this back to see you get the same expression. Is that right? So I go to the next one. It's the minus sign. What should I write? I pulled 2 out, so 3 is left. I pulled a out, but x is left. Is there anything else left? No, because I had only one of these factors and I pulled that factor out. Is that right? It means that if you multiply this back here, do you agree that I will get the same thing back? 2 times minus 3 is minus 6, a times x is ax, and this times that becomes, that's correct. And what happens for the last one? It becomes plus 5y. So I don't need that. I keep it here. This is the first thing I expect you to do. And by the way, this is not the creativity part of it. Because I told you the first question you need to ask yourself in factorization is that Ma3c method applicable? Is it possible to pull something out from all the terms? If you can, you have to do this one first. But you shouldn't stop here. First of all, not because we see, this is messy. You know, you have 2 pairs of brackets, and then you have another pair of bracket here. So you don't leave it like this, because whenever you can simplify something, you should simplify it, even if it is not mentioned to you. Okay, so this means that I will not stop here. I will not mess around with this one, because this is already in factorized form. It's a product, so I don't change it. There is nothing I can do here. But this one, from factorization point of view, it is not clear if there is anything I can do. But from simplification point of view, yes, I can. So I shouldn't stop there. So I multiply this by 2, so it becomes 6x minus 2y. And then I have minus 3x, and then plus 5y. Okay? So I shouldn't stop here because I can still simplify. So I will continue, yes?
I have a question. What happens to the x from the 6ax, minus 6ax?
What happens to what?
Because it's minus 6ax times 3x minus y, right?
Yes,
So
if you multiply this back, you will get this one.
Oh, so we move the 3x minus y to the left side. Okay, no, I get it. My bad.
Yeah, because that's a product.
Okay, gotcha.
That is a product. Okay, but should I stop here? No, because I can simplify, yes? And then this was 2a, and then 3x minus y. 6x minus 3x is what? 3x. And then minus 2y plus 5y is what? 3y. Okay, but now I try to design it in a way to see if you are careful about what is happening. It was not easy to see this is going to happen, but it happens coincidentally here, that again you get a common factor, which was not easy to foresee before reaching to this stage. Even I couldn't. Of course, I designed that intentionally, this to happen, so that you become observant about what is going to happen. So, if you stop here, then this is not complete yet, because coincidentally, I can pull a 3 out here. And you have to do that. Okay? So then you pull a 3 out here, instead of leaving 3 here, because that's a product, people prefer to move 3 here, multiplied by that, it becomes 6a. So that is the final answer that I expect you to write. Okay? And it was not, I couldn't even foresee that this is going to happen if someone gives this to me. This is a coincidence that I get another common factor. Yes?
Can you just repeat the next part?
Here, if you stop here, it's not complete because still you can pull 3 out.
So you
Okay.
multiply 2a.
Yeah, I pulled 3 out. But
Exactly.
this is 3 is here. Of course, this is the product of some numbers, yes? So you don't put 3 here because 2 times this times that times 3. 2 times 3 is 6. Yes? Is that clear? So even though it's a Ma3c lesson, but I try to make it a little bit challenging so that you become observant about the process of factorization. You have to continue until it is complete. It means no longer you can factorize any kind of data terms. So I would say that 95% of the problem is finished here, but it is coincidence that the 3 is another factor that I can pull out. You have to do it. Any questions? Okay, so the next question, I have written it here on the board. Of course, you can see here, so I am writing all these questions here, okay? So the next one again, the first thing comes to mind is the Ma3c method. Is it applicable here? Is Ma3c method pulling out a term from all the terms is possible? If it is possible, do it. Don't even bother to think twice, yes? So between numbers, I can pull 3 out, and between x, I can pull 1x out. So this is the first step. Don't even bother to think much, okay? So I pull a 3 out, and I pull x out, and then what do I mean? I have to fill up these question marks here and there, because I have 2 terms. How should I fill it up? In a way that when I multiply this back, I will get that one. So what should I write here? X to the power of 4 minus, I have to write something here so that when it is multiplied back, I will get this one. What is that? 48 divided by 3 in your head, 16. X divided by x is 1. We don't write it. So what is left? Only y to the power of 8. Yes? Is that right? This is the first step. At least it is a product. But can I continue this one? Then this is a Ma3c problem. You need to train your eyes to catch this pattern. This pattern is the conjugate pattern. But for the conjugate pattern, I need what? Let me write it here. I need this pattern. The difference between 2 complete squares. Okay, they are not complete squares, but you can put them in the form of a complete square. How? This part you don't need. You can do it in your head. But for your understanding, I'm writing. instead of this one, I can write it as x squared to the power of 2. Because I want to put it as a complete square. And what can I do for this one? I can write it as 4y to the power of 4 to the power of 2. This one in exam you don't need to do it. You can do it in your head. And it is even better to do it in your head. But for the future reference, I'm writing it. Everyone happy with what I've written? Yes. But now can you see that I can give the role of the box to this guy and give the role of the circle to this guy? If you do not look inside, you have this pattern. What is the answer to this pattern? It is box minus circle times box plus circle. So I use that. So this becomes 3x. Box, which is x squared, minus the circle, box plus the circle. Do you agree with me so far? Okay. But again, if you stop here, it's not complete because there is another conjugate pattern revealed here. Yes, that's also the difference of two complete squares. There is no formula for the sum of two complete squares. If you have the sum of the complete squares, you stop there. But if you have the difference of two complete squares, you can continue. Okay, can you do this part in your head? So what I do, I copy and paste these parts that I'm not going to touch. So can you tell me in your head, how can I complete this without going through this step? Yes, is this the difference of two complete squares? Yes. The box is x. Can you tell me what is the circle here? 2y squared. Yes? Because 2y squared to power 2 is 4y to the power of 4. Yes? So, but then it means that box minus the circle times box plus the circle. Of course, the order is not important. If you have written it in a different order, it doesn't matter. But these are the factors that you have to write down. And then we cannot continue anymore, so the factorization is considered to be complete here. So whenever you can apply the Ma3c method, means pulling out a factor from all the terms, always do that. So I did it here, and it solved my problem. I did it here, it didn't solve my problem completely. Then I realized that there are two conjugate rules coming one after the other. Is that clear? Okay, so it was not hard. Let us go to the next one. Do you see the pattern there? So now I have three terms involved. When it becomes three terms involved, what you need to think about? A squaring rule. Okay? But is it a squaring rule? For a squaring rule, how many complete squares I need? No, how many complete squares? I need three terms, I have. How many complete squares I need? A squared plus or minus 2ab plus b squared. A squared and b squared are complete squares. I need two. Okay? Do I have all of it here? Yes. I have three terms. I have two complete squares, but it is not immediately guaranteed if it is a squaring rule. You have to check it out that the middle term is the appropriate term that you need. Is it? Take the square. If you go, you can go to a scratch paper. You can take a square root of that one. It becomes 3a squared in your scratch paper. Take the square root of this one is 2, and then the middle term is supposed to be 2 times the first one times the second one. So you multiply that. What do you get? You get 12a squared. So that is the appropriate term. Okay? If it is 11a squared, it doesn't work. It has to be only 12a squared. So everything we checked, so it works. So the answer is very simple. What should I do? I write 3, what? A squared, 2 to the power of 2. What is the middle sign? Because this is negative, this is negative. That's it. I cannot continue any further, even though it looks like a conjugate rule, but it is not. Because these are not complete squares. For conjugate rule, we have to have the difference of two complete squares. Is that right? Okay, we go to the next one. We also solve these kinds of problems together. Do you remember the method that you actually learned this year was grouping method? Okay, sometimes grouping in 2 works, sometimes grouping in different order works, you know. I don't know how many of you could solve this. Might be some of you jump to the conclusion that this is the conjugate rule. So let us follow the conjugate rule. Yes, you can do the conjugate rule for this part, but this will not work. Let me review it. If I want to use the conjugate rule for this one, what happens? It becomes x minus 2y times x plus 2y for the first two terms, then I have to copy and paste the leftover. Okay? If I say this one is equal to this one, is it true or false?
It's true.
It is true. But is it a factorized form? No, because that is not a product. What is this at the end? It is a sum. A sum of this plus that. So it's not a product. So even though this one is equal to this one, this is not a correct answer to this because this is not what I want. I want you to factorize. Okay, so I don't know how many of you worked on this problem, but the trick, because here I have to continue, I cannot teach everything again, I try to explain. I want to keep this alone and I will want to group these three together. Okay, so can you do that? I want to group these three together, okay, but I want to make a squaring rule out of these three. The problem is that I have the wrong sign. Yes, what do I mean by wrong sign? In a squaring rule, the squares should be positive. The middle term can be positive or negative, but the squares should be positive. Unfortunately, here the squares are negative. But this, I told you a trick for it. Whenever this happens, you have the wrong sign. What was the trick?
If you want to find some coefficients, you need to.
Yes, you pull a minus sign out. Yes, whenever you need something and then unfortunately you have the wrong sign there, remember this trick. It might be possible that I pull a minus sign out and it works out. Okay, and it will work. You see, between these three, I pull a minus sign out. This is negative. When I pull a minus sign out, this one becomes positive. This one is already positive. When I pull a minus sign out, it becomes negative. And it is negative, now it becomes positive. Okay, make sure that you understand what I have done. Yes? You see, one part of it is creativity and hard work, but sometimes some part of it is memory, yes? So you need to remember, if you have a wrong sign, what is the trick? The trick is pull out the minus sign. And now, can you tell me what happens here? Do you see this pattern? So I just copy and paste the first one. I copy and paste the minus operation here. And then what is this one? This is this group up there. Yes? So what is the answer? It is 2y minus 1 squared. Always double check. The first one is squared, that's correct. 2 times the first one times the second one with the minus sign, that is also correct. And this one to power 2, that's correct. So that's it. But should I stop here? Because you know that so far I haven't factorized anything. Is it a factorized form? No. Is this equality true? Yes. But it is not still a factorized form because that's not a product, that's a difference. But which pattern reveals itself now? The conjugate. Because this will play the role of your box now. The whole expression here will play the role of your circle. If you do not look inside, what happens? It is box squared minus circles. So what should I write? I would write box minus circle. A common mistake is people write like this. Box minus circle, box plus circle. You see the flaw?
No brackets.
What?
No brackets.
Yeah, you have to put brackets, or you have to take care of the minus sign in your head. If you write this, it is wrong. It doesn't hurt if you write something like this in your notebook, cross it over, okay? But this is not the correct one. The box is correct, minus the circle. This is your circle. Yes? And of course, we don't write a lot of pair of brackets. If I can remove them, of course I will remove them. Here, I can just remove it simply without even caring anything, because that's a positive sign. If I move it, it will not change at all. But here, if I want to remove the pair of brackets, this minus sign not only goes for the first one, but also for the second one. So it becomes x minus 2y plus 1. So the previous way that I wrote it was wrong. This is the correct one. And this is what I expect you to write as the factorization of that problem. Yes? By the way, we worked on these problems, so this is not creativity part of it. We had some experience from this, if you remember that lesson. It's always good that after 1 or 2 weeks we review the lesson as a homework assignment, because you can also refresh your memory. Yes?
Can't you also factor the x minus 2 y plus 1?
No, no. This is different, you know. So a times b plus a times c, I can factor a out. Yes, but if I have a plus b, a plus c, how can I pull a plus out? Yes, this is not possible. If you write a plus b times c, that's wrong. Yes? You can pull factors, not summands. Any questions so far? Is that okay? Okay, let us go to the next one. So here, what do you think I will do first? What do I do first?
Pull the B out.
Not only B, more than B. You should factor as much as you can if Ma3c method is applicable. It is applicable. Of course, B is a common term, but I have more common terms, yes, which is a to the third as well. So a to the third is common to all of them. B is also common to all of them. So at least do this one, because that's a Ma3c. A Ma3c student, in principle, can understand how to do it first. So B pull a to the third, a to the third, and B out. So, okay, 1, 2, 3, 4 terms I have to answer. How? I have to write something so that when I multiply this back, I will get the same thing. So what should I write here? How many a's I need here? A to the power of 3. Do I need any b's?
No.
No, because this multiplied by this is already here, so that's okay. The next sign is negative. What should I write here? A to the power of 2. That's it. The next one is minus a. The next one is plus 1. That's the first step. Again, you see, you're following the memory. It's not hard. It might be a little bit complicated, but the first step is just following what I told you. Okay? But hopefully it's a hard question. It's an A-level question, so it shouldn't be the complete solution here. So can you see what we can do? Now we think about grouping. Because conjugate pattern is not here, that rule, the squaring rule, is not here. I have 4 terms. So the only method available probably is to think about grouping. So how do you think we can group them? Okay, so let us take these two. Might be you think in a different way, but this is one way, and I will take these two. But let us try to work it out. So what does it mean? I copy and paste this part. But now you know that sometimes grouping is successful, sometimes it's not. If it is not, I have to do another way. Okay, but let us stick to this one to see if it works. If I insist to do this grouping, then everything becomes clear. What should I do between these two? What should I do? Okay, one thing that I want to mention, do you remember you learned factoring very good when we were doing it 10 days back? Okay? And now the problem is not you didn't learn. For some reason you forget. And let us happens that this is the hard part in Sweden, that what you want to do in May you need to remember these. Okay, so I don't know how to solve this problem, but I want to make you conscious about the problem is not learning, because I'm sure that we learned very good, and some of you actually did hard questions on their own without me explaining it. And now it seems that it was ages back. At most it is 10 days back, I don't remember, but it might be 1 week back. So this, and most of you, I see question marks in your head, what is this doing, so it is completely out of your mind sometimes. You need to find a way to remember things. Okay? So I don't know what you want to do. It's a very hard fight for you because you have been trained in this way for 9 years now, or I don't know how many years. But then you have to change the habit. But sooner better. If you don't do that, you will have a problem in the university. Okay, try to do it, okay? So, between these two, I factor a squared out. So what is left here? A minus 1. Agree?
Yes.
Okay, now tell me, what do you think I will do next?
Put minus.
pull a minus sign out. Because it's a minus 1. I have the wrong sign here. Whenever you have the wrong sign, yes, you pull a minus sign out. Is it helpful? Because if I pull a minus sign out, what will happen? This is already minus, becomes positive. This is already positive, becomes negative. Why this is good? Because now a minus 1 is my common factor. I can pull it out again. So what happens? A cubed d is already there. A minus 1 I also pull out. Okay, can you tell me what is left here now? A minus 1 of this one is gone. What is left? A squared. Okay, tell me what should I write? Say something? Minus 1, yes, thank you. Okay, is that enough or not? I want you to see it's a product of 4 terms, a cubed, b, a minus 1, a squared minus 1. But is it complete or not?
No.
No, because what? The last one is which pattern? Conjugate. So you have to continue again. Okay? So this becomes a cubed b a minus 1. How many of you can do this immediately in your head? What happens? Instead of a squared minus 1, if I use the conjugate rule, what should I write? What? No, if you don't say, I will stop here. You have to say. What should I write here?
A squared minus 1.
No, what should I write instead of a squared minus 1?
You mean the square.
I don't mean anything. Do you know what I'm doing? I'm factorizing. Okay, so don't ask strange questions. What should I do? Yes?
A minus 1, a plus 1.
That's it. This is my answer, okay? You are not making philosophy, yes? So a minus 1, a plus 1. Yes?
Yes.
But if you are a good mathematician, you shouldn't stop here because again, coincidentally, something happens that people don't write a minus 1 multiplied by a minus 1. People write a squared. So then what do? You write a cubed, b. I prefer to write a plus 1 first. That's subjective. A minus 1 is a minus 1 squared. So that is what I expect you to write for the factorization of this expression. So you see, I designed the questions might be you find them hard. They are not hard. It's an algorithmic question. You are following my advice step by step and it is finished. Okay. Is that understandable?
Yes.
Okay, that's the end of the story there. Okay. This is hard a little bit. X to the 4th minus x cubed minus, I didn't know because immediately I published this homework. I was hoping that by the knowledge and you learn from there, you can answer this question yourself. This question, I agree. We didn't do something similar to this when I was teaching. But I was thinking that you have time at home. You have time for trial and error. Yes? Okay. You have time for trial and error, but you have to develop the attitude for trial and error as well. Okay? Which is the most important part of it. Okay. I don't know, that was a technical problem, but do you see what we can do, or any one of you could solve this problem before? And by the way, from now on, when I give a question, either use, let me show you the recording again. Okay, so here, if you see, I have asked you to either use the equation editor to type your solutions below or use the scanning feature of exam.net to upload your handwritten solutions. Might be you don't know how to do it because that's a very, very good feature for homeworks. For exams, we don't use them, but for homeworks, it's a very good option. I will talk a little bit about that later for you as well, okay? Okay, but let us come back to this problem. Do you have any idea how to solve this problem? Yes?
I'm guessing we fact like get x, since x is common, and the x is power 4x minus, or x
Between these?
No, only the x is power 4, power 3, power 2. Only those ones, I'm guessing.
Okay, so let us do that. This is trial and error. If I do that, I factor x squared out. What is left for me? X squared minus x minus 1. And then 2x minus 1 is also there. Is it useful? So this is one trial and error, okay? So it doesn't work. Another one. Yes?
Can't you do the same thing but also pull it out of the 2x?
Okay, let us do that. X, then I have to factor x out. Do you agree? Doesn't work. So this is the second one. But it's good, okay? Okay. Yes? Grouping. Which kind of grouping? Here, because it's a little bit harder than the problems we solved together before.
But you said we should group like 3 of them and then 2.
3 of them, you mean these 3?
Mhm.
We did that before.
Yeah.
It didn't work. Yes? Yes?
Can you group x to the power of 2 and 2x and 1?
Which one?
X
This one, and that one? Yes?
Yes. Okay. Then it's
It works. Okay. Okay, can you finish it yourself? Because you are right.
very good.
So how should I do that? The first step is to you group these 2 and then these 3. This is your idea. It's one possibility. Let us try it out. If you say let us take these 2, then it means you factor x cubed out. Let us do that. So this becomes x cubed. What is left for me? X minus 1. But you know the idea of grouping. The idea of grouping is what? I don't remember everything, by the way, but I remember the important points. What is the idea behind grouping? You, after grouping is done and factorization in each group is done, a new common factor emerges. If you don't have a strategy, trial and error is useless, because how many times you want to do trial and error? Okay, so then what do you suggest here? Because now, if you know the strategy is to do something here that either x or x minus 1 appears, so that will be my common factor to pull it out. So can you yourself finish it?
I wrote minus.
Exactly. Because now you see, this is the x minus 1 squared pattern, but with the wrong sign. And then you learn the trick. The trick is to pull a minus sign out. Let us do it 2 steps. Everyone agrees with this one so far. Might be you say it is not useless, Babak. It's not useful, Babak, because x minus 1 does not appear, but it will appear here. Yes? You have to be patient a little bit. So x to the third, x minus 1. What can I write for this one? X minus 1 squared. Yes? So I have x minus 1 here. So what can I do now? I can put, now you pull x minus 1 out. Because this is x minus 1 times another x minus 1. So x minus 1 appears as a factor here. X minus 1 appears as 2 factors there. So 1 factor is still in common. So that was a successful grouping. Okay? So what do I pull out? X minus 1. What is left from the first one? X cubed. What is left from the second one? Minus x minus 1. How many of you agree with that one? Yes or no?
Yes.
Okay. But you are those kind of people to fall the same trap all over your life. Yes, I just told you, be careful, this is wrong.
No.
You have to write minus
Bracket.
brackets. Okay? In 10 minutes, I had to repeat this again. That is the big problem. You need to take lessons from your mistakes. Otherwise, you will make the same mistake every time you face the same problem.
Doesn't that,
Okay? Yes.
doesn't that mean that
Then I have to remove it. Yes? So what will I do? It becomes x minus 1. And then it becomes x cubed plus x plus 1. Yes, so that's your factorization. It's a third one. I agree with you. You might say, Bob, like, how should I know that I cannot factorize it more? Okay? Now, in your lesson, you are not expected to see if you can factorize this more or not, but let us say I give you GeoGebra. By graphing, in principle, you can understand that you can do it or not. Okay, so be active in your learning. You can go here. For you, if you start, I don't know even myself, because that's a third degree polynomial. To judge that if it is factorizable or not is not that easy. Okay? But that's why I'm saying that if you face a third degree polynomial like this, you consider it end of your story. Okay, so that's finished. You stop there. Okay? But if you really want to see if I can factorize it more, you can factorize it, but not in the integer numbers. In your lesson, factorization only works with integer numbers. Okay? Not decimals and things like that. You have to stick with that. So you see, I will consider this a hard problem, but you could do it. In principle, every one of you can do that. Okay? It was not very hard. Okay, so let us go here. What do you think about the question here? How can I do that? Yes?
I'm not sure, but you could group x squared plus x and y minus.
This one and that one? Yes? We do the trial and error. This trial and error means doing homework. That's it. When I ask you to do a homework, I don't mean to do something strange. It means doing the trial and error. Yes?
I don't mean that. I mean the x squared plus 10y minus y squared. Because that is a square.
This one, this one, this one?
Yeah. Because that's a square.
This one and that one are not a squaring pattern. If you mean these three.
Yeah.
Because that is x,
Square.
that is y. It is not a complete square because there is a wrong sign. On the other hand, this is not 2 times the first one times the second one. Because 2 times the first one, x should also be here. So it is not exactly that method. Yes?
You can use the x squared and the minus 25 and then the 10y and then y squared.
Okay, so let us say that I do it in a scratch paper. x2 minus 25, and then between these you want to factor y out?
Yeah.
Okay, let us say do that. Okay, this is not hard to see immediately. It is not working because what happens, even if you do this, it becomes x minus 5, x plus 5. This becomes 10 minus y, but there is no common factor. So this grouping is not successful. Yes?
Can you pull out 5?
What?
Can you pull out 5?
From these two, yes, but not in total.
Then shouldn't you group them?
So how should I group them? So these groupings that you suggested didn't work. So you have to find a way to do another one. It's not very hard problem. Yes?
Do the conjugate rule on x to the power.
Conjugate rule does not work for this one. Let us do that, yes? It becomes x minus y, x plus y. And then these are left alone. I can factor a 5 out at most. So it becomes 2y minus 5. Is there any common factor emerging? No. Okay, so that is why every grouping takes nearly 10 seconds to check. So 4 grouping, 40 seconds. But the problem is that you don't have patience for 1 minute. Okay, so you have to find another way. Okay, these things didn't work. What is left? What is left? Yes? I don't want to answer every factorization question. Anyone else? Anyone else? Okay, so what we want to do in the exam? I give you this, you don't find any way. You want to forget about that question? Yes, please, Zoya.
Group 10y, y squared, and
These three. Yes? So, yeah. But how? What should I do? If you want to group them, that is correct. But I want you to understand, what pattern is this? It is close to which pattern? Squaring rule. But it is not exactly that one. You see, I am doing the same thing over and over again. Okay? So, the complete squares have the wrong sign. Pulling out the minus. Yes? Okay? So what should I do? I would write x squared. Between these three, I pull a minus sign out, but I try to arrange them. In a squaring pattern, the square comes first, that square comes last. This is the middle term. Yes? Because if I multiply the minus sign back, minus y squared, yes, that's correct, plus 10y, that's correct, minus 25, that's correct. What is the answer now? This part is what? It is what? Y minus 5 squared. Yes, agree? Always double check. The first one squared, 2 times the first one times the second one. It is really this one squared. And which pattern is this? Is the factorization finished here? Nothing has done actually so far. up to factorization. Factorization means writing a product. This is a difference. But it is, which pattern? Conjugate. This plays the role of box. This plays of the circle. So I would write box minus the circle, box plus the circle. Agree?
No.
Agree or not? The people said yes. Again, they fell to the same trap in 5 minutes.
Bracket.
Yes? Yes, you have to put a bracket. But now that you are more experienced, do this in your head. There should be a pair of brackets here, a pair of brackets there. But do I need this pair of brackets? Because that's a positive sign, I don't even bother to write it. But here, I bother to write it, but I think it in my head. It becomes minus what? Plus 5. That's it. Is that right? Understandable or not? Okay. Let us jump to the next one. So what do you think here? What kind of pattern is that? Anyone else? Anyone else? Yes?
I forgot the name, but it's the one where you do the box squared.
Conjugate.
Yeah, conjugate.
And even the Swedish is conjugat. I mean, that's the same name. Okay, so conjugate. That's a conjugate pattern immediately. But before doing that, I need two complete squares. Is this one a complete square? It is. Power of 2. And then I need a minus sign. I have it. Is this a complete square? It is, yes, but it is written in a not correct form. You don't have to do it, by the way, in the exam, and it is better not to do it, but I want to do it because I want you to understand. How can I write this as a complete square? I want to put a power of 2. Can I? What? I should write 2? Yes? Do you see that this equality is legal? Yes, what I have done is legal. But what is the benefit of doing this? Because now I have the box squared minus the circle squared. Yes? So can I continue? Yes, that is exactly the conjugate rule. So it becomes a squared plus b squared minus 2ab and a squared plus b squared plus 2ab. Do you agree with me or not? Yes? So I was able to factorize because now it's a product. But is it complete? This is the important question you have to ask yourself every time you finish a factorization. Is it complete? Is it? Is it? Is this complete? Can I factorize this more? What should I write? Can I factorize this more? Yes? What is the first one? A minus b squared. And what is that one? A plus b squared. Yes? So this is the complete one. If you stop there, it's not complete yet. Yes? Here, exceptionally, you can do it in a very strange way. Usually when you want to factorize, you do not expand. But this is one of those cases expansion works. Because expansion and factorizations are actually opposite, going in opposite directions. So when we are thinking about factorization, we usually never think about expansion. But this is one of those exceptions that if by some reason you try to expand, it also works. Let us see why. So, if I expand, apparently I am going against the logic of factorization. But sometimes thinking outside of the box also is good. If I square it as if I am solving the expansion problem, what happens? This becomes what? A to the 4th, 2 times the first one times the second one. The second one is squared. But then what do I have? Minus 4. This is a coincidence that is working. Because 2a squared b squared minus 4a squared b squared can be simplified and written like this. Do you agree? Yes or no? But now can you see which pattern emerges coincidentally? There is nothing that I can say for sure, but this coincidence works here. What can I write? Is this a pattern?
Yes.
Yeah.
Which pattern is that?
Squaring.
Squaring pattern with what? A squared and b squared involved with minus sign in middle, yes? Do you agree or not?
Yes.
Because the first one squared is this one. 2 times the first one times the second one. The second one squared is that one. Okay? But is it finished? No, because this one is now a conjugate rule. So it becomes a minus b, a plus b. So this becomes a minus b, a plus b, and then totally squared. But then if I have a product squared, it becomes the first one squared multiplied by the second one squared, and then you get the same answer back. But that is just a coincidence, because the logic of expansion is completely in the wrong direction of the logic of factorization.
I didn't understand how the minus 4a squared b squared made it into b to the power 4.
Oh, okay, no, sorry. This is b4. Thank you for letting me know. Because the first one squared is a4. Thank you very much. 2 times the first one times the second one to power 2. That was b4. And this b4 is left.
Oh, so it cancelled.
No, I didn't cancel. a4 is a4, b4 is b4. 2a squared b squared minus 4a squared b squared becomes minus 2a squared b squared.
Oh, okay.
Yes? Any questions? Okay, there are 2 more left. Okay, I want to wait for you. I mean, can you do this now yourself? Okay, because at least let us do some practice today. I want you to pause recording a little bit and give you the chance, by the experience you got so far, try to solve the last ones. Might be they are harder than the previous ones, but now you have more experience. Hopefully you can solve better. Okay, do you want to continue more? Okay, because we end at 11:40. 5 minutes more, okay? I would recommend you to solve the last one, even though it is more tedious, I would say. But the idea behind that might be a little bit subtle to discover. I'm not demotivating you if you are stubborn and still want to continue with this, do that. But this is at least the first pattern shouldn't be hard for you to detect. Okay, so let me do this one. Let me do this one first. So, Muhammad, can you tell me what did you do for this one? Because the idea of this problem is novel. I didn't give you any explanation of how to do it, yes?
I use a power 2,
Yes.
the power 2, and 2ab.
Yeah, so that was a very good observation. I mean, by practice, you become faster to detect the pattern. Okay? And then, so why, let us say that, everyone understands that, let us say, and then we group these together and this one alone. That's why I'm saying this, you have to be creative. But of course, one of your peers actually could do it. So it is possible. Okay? So then what we should do, if I take these 3 together, so why, well, let me just copy and paste. You know that what is this pattern at least, yes? So I put them in one group, and then I told you that I want to put one alone. Then between these 2, I can factor a 2 out. But if I factor a 2 out, it becomes, I mean, you can write it as, let me write 2, and then b minus a. Yes? But you might say, okay, what is the benefit of that? There is no common factor emerging, so it should be, I shouldn't consider this successful, but it is. What can I write here? I can write a minus b to power 2. Yes? And then you see this is not b, it is b minus a. I need a minus b, so that's the same trick. So what should I do? I pull a minus sign out, and it becomes a minus b immediately. And then I have 1. I mean, now this is the only new part to it. Of course, grouping was new, but this one is new. Can you see the pattern now?
Yes.
What pattern is that?
Square.
This is a squaring pattern, but this is playing the role of the box, you know? If I just write box squared minus 2 box plus 1, can you see immediately this is what? This is box minus 1 squared. Do you see that? Okay? But that is the same thing, but a minus 1, a minus b is playing the role of your box. That's it. Box squared minus 2 box plus 1. You know the answer. It is the box minus 1 squared. Yeah, that was a little bit hard. Not tedious, but understanding the grouping might take time. But it is possible because actually one of your friends did it. But this one is tedious. But it is, I wouldn't consider this a hard problem. Let me see if I'm recording this. So, what is this pattern? Immediately you need to be able to detect this pattern. This pattern is extremely easy to detect. What is that? Conjugate. So let us do that. Okay, so instead of doing, if you can do it in your head, it is better. So do you see that this is a complete square? Complete square of what? Of 2ab. Yes? So it becomes 2ab, the box minus the circle. I hope that you don't fall into the same trap over and over. Yes, this is wrong. Yes? So what should I write? And then 2ab plus a squared plus b squared minus c squared. Yes? At least we managed to write it as a product. But as you always know, might be hard problems are not easily completed. Okay. But here, I hope that everyone, do I really need this pair of brackets? Because that's a positive sign, so let me clean it. But here, do I need this pair of brackets? Yes, but I have to remember to multiply this minus sign. This becomes minus, this becomes minus, this becomes plus. So let me remove it and then make it minus, this plus. Okay? Now you need to concentrate on two pieces. This problem is a simple one, not hard one. This is also simple, not hard one. Then you can do it separately and combine them into one problem. Can you see the pattern here? This is now, I think, should be simple for you because you immediately see that I can group these three together. Yes? What happens? It becomes a plus b squared. Do you agree? And then minus c squared. Is this pattern good? Yes, because this is also another conjugate pattern. So far, so good. Let's keep it. But what can happen here? I have a little bit of problem. What that problem is?
2 minuses.
Yes, I have 2 minuses. I had the wrong sign. But you know the trick. That's repeating the same trick over and over again. How many times this session? Yes? So what I will write c squared first. And then minus, I will take the minus sign from these two out. So it becomes a squared plus b squared. And then this one becomes negative 2ab. Do you see that? Yes? This one can be written in that way. But now again, this becomes c squared minus what? A minus b squared. And now this one is a conjugate pattern. That one is another conjugate pattern. So 2 conjugate patterns and we are done. So what can I write for this one? Box minus, do it in your head. What happens? Minus the circle. Because minus a, again you are saying minus b. Yes? No, I am doing it. The box, okay. C minus brackets, or do it in your head. Minus a plus b, c plus a plus, plus a minus b. That is the factorization of this. Factorization of that one is a plus b minus c, a plus b plus c. Yes, so that is the factorization of this one. Of course, yeah, these 2 questions you might not receive in the national exam, but I would say that this is not hard. Okay? And I'm sure that you learned it this lesson, but I don't know, you need to find a way to review things a little bit so that you can remember it. Okay? Any questions? Okay. Thank you very much.